Hi again. Today I will discuss about understanding aircraft stalls. Why do aircraft stall? An aircraft stalls when the smooth laminar airflow over the wing's upper surface separates and becomes turbulent. This happens when the critical angle of attack is exceeded regardless of airspeed. As a result, lift is lost because the disrupted airflow increases pressure on the wing's upper surface. The only way to recover from a stall is to reduce the angle of attack by relaxing back pressure or pushing the control column forward. What affects stall speed? An aircraft always stalls at a constant angle of attack, known as the critical angle of attack. Since most aircraft lack angle of attack indicators, except for some modern electronic flight displays, pilots must rely on airspeed indicators. However, the speed at which a stall occurs varies due to several factors. Weight, actual weight, load factor g-forces in turns, center of gravity position, altitude, wing design and lift characteristics, configuration, for example flaps, landing gear position, propeller and engine power. How does weight affect stall speed? A heavier aircraft stalls at a higher speed, since lift must always counterattack weight. An increase in weight requires an increase in lift. Because the stall occurs at a fixed angle of attack, the only way to generate more lift is by increasing speed. Mathematically, stall speed is proportional to the square root of the aircraft's weight. How do wing design features delay a stall? Wing slots. These keep airflow attached to the wing for longer, delaying the stall. By re-energizing the airflow, they allow the wing to generate more lift at lower speeds. Wing shape. A lower angle of incidence and increased chamfer, particularly near the wingtips, also help delay stall onset. What changes an aircraft's angle of attack at stall? As a wing stalls, the center of pressure moves rearward. In most aircraft, this shift naturally causes the nose to drop, aiding stall recovery. This design helps maintain stability by ensuring the stall starts at the wing root, where control remains possible. How does stall speed change at high altitudes? At high altitudes, stall speed increases due to two factors. Mach number compressibility effects. Changes in air pressure distribution increase the effective load on the wings, raising the stall speed. Airspeed indicator errors. The difference between the indicated airspeed IAS and the equivalent airspeed IAS grows due to compressibility effects, causing the IAS stall speed to appear higher. How does the center of gravity affect stall speed? A forward center of gravity increases stall speed because the aircraft requires more lift to maintain level flight, increasing the necessary airspeed before a stall occurs. What is superstall? A superstall or deep stall is a condition where an aircraft becomes unrecoverable from the stall. This occurs primarily in high T-tail rear-engine aircraft, where the stall wing creates an increasing nose-up pitch tendency. The most infamous example was 1972 British Airways Trident crash in Slough, England. Superstall characteristics. Nose-up pitching tendency. At stall speed, the aerodynamic center moves forward, increasing the nose-up effect. Wingtips stall first due to higher loading, shifting lift distribution forward. Forward fuselage lift increases, worsening pitch-up tendencies. Ineffective tailplane. As the aircraft stalls, the disturbed airflow from the wings reaches the highest mounted tailplane, reducing its effectiveness. Without clean airflow, the tailplane cannot provide the necessary nose-down pitches to recover. How do aircraft prevent stalls? Stall warnings. Audible alerts or stick shakers warn pilots before a stall occurs. Stick pushers. In aircraft prone to superstall, an automatic system pushes the control column forward to prevent the stall from developing. These systems typically rely on sensor that measures the aircraft's angle of attack and provide feedback before reaching critical stall conditions. That's all today. Next episode, aircraft instability and its implications will be explained. Join us the next time as we discuss the different types of aircraft instability and how they impact the flight safety. Thank you for listening.